So consider this given problem statement. So it says that if sum of all possible real values of x for this given equation, that is k. So in that case, we need to compute the value of 8 times k minus square root of 33 divided by 2. So let us try to solve this one. So first of all, we'll consider the domain conditions. That is, if you consider the base which is given as x minus 3, this has to be greater than 0, and at the same time this x minus 3, this should not be equal to 1. So from this we can say that x must strictly be greater than 3 and x must not be equal to 4. So this for the base. Now talking about the arguments. If I talk about the arguments, so in that case x square minus 9, that has to be greater than 0, and at the same time x plus 1 greater than 0. So combining each of these, we can mention that these are these are already these are already defined if x is greater than 3. So while solving this one, we'll make sure that whatever roots we figure out, this has to be greater than 3. Now going for further, so I'll take this equation and resolve this. So this is the given equation to us. Now we'll use the property of logarithms. That is, first of all, I'll arrange these terms properly. So this quantity as it is, and we'll subtract this term on both sides. So this minus this particular quantity, this is equal to 2. Now I'll be applying the property of log. So here subtraction to division. So so in this case I can write log of base x minus 3, and in the argument this is x square minus 9, and denominator will be x plus 1. Now this is equal to 2. Now we'll convert this logarithmic format into exponential form. So this can be written as x square minus 9 divided by x plus 1. This can be written as x minus 3 whole square. Now further, this x square minus 9, so instead of this 9 I can write 3 square, and I can apply the formula of a square minus b square. So this can be written as x plus 3 times x minus 3, right? And on resolving this further, we get here this x plus 3 as it is, and if you observe x minus 3 here and x minus 3 whole square here, so this term gets cancelled out. So this is x minus 3 only for once and x plus 1. Now on resolving this further, so this one as x plus 3, and this will be x square minus 3x and then plus x minus 3. Now on resolving this entire equation, we get x square minus 3x minus 6, that is equal to 0. Now if I use the quadratic formula directly to get the roots, so x will belong to this two numbers, that is 3, one with addition and one with subtraction, two different roots. That will be 3 square plus 4 times 6, that is 24, divided by 2 times 1, that is 2. Now taking this further, so here we can say that one of the root is, you can observe clearly, 3 minus square root of 33 by 2, and this is clearly less than 3 if you observe, right? So hence this has to be rejected. So we can say that the acceptable only acceptable value will be equal to with the positive sign, because that is something which is satisfying all the given constraints, that the domain constraint and this domain constraint for this base and the argument, right? So this is the answer, and hence this becomes the value of k. Now we need to compute this particular expression, that is 8 times k minus square root of 33 by 2. Now this is something that we need to compute. So instead of k, I'll just substitute this particular number. Now on further solving this, this turns out to be 12. So you can see that plus square root of 33 and negative square root of 33, this gets cancelled out, and this 2 times 4, that becomes 8, and 4 times 3, that is 12. So therefore for this problem statement the answer is 12. So 12 is the answer for this one. So I hope it is clear to everyone.